when squares, or exponents of 2, undo each other. They're the inverse. We've also learned how to find the square root of something. We learned that square roots can have positive and negative answers. Let me tell you that we also know that when a square root comes out perfectly to a whole number, that's called a perfect square. Take this for example. The square root of 200 equals 14.142135, on and on and on. The numbers go on forever and don't follow any pattern. Because no number times itself equals 200. This is not a perfect square. So there are perfect squares and not perfect squares. That's going to come in handy a little bit more tomorrow. So what do you do with this? Well, let me tell you this before we get to the next problem. The square root symbol in Gemdas, in order of operations, falls under G, the groupings. So look at this problem. It's on page 277 in your hardcover book. It wants us to simplify this expression, the square root of 13 squared minus 12 squared plus 15. Gemda says to do groupings first. The square root symbol is a grouping symbol. Within this square root symbol, we have to look at what's underneath it, and then we have to start with any other groupings. Nope. So let's go to exponents. So 13 squared is 169, minus 12 squared, which is 144. So I've simplified my exponents. Then under this grouping, do I have multiplication and division? Nope. So let's subtract. 169 minus 144 is 25. Now, finally, when I have a single number here, I can take the square root of it. Square root of 25 is 5. We're going to assume a positive answer of 5. 5 plus 15 equals 20. 20 is the answer. I want you to try the problems on page 277, following order of operations, and then go on to the next slide to check your answers.